today, and a great group of folks lined up to talk with us. So first of all, I'd like to introduce you to Courtney Cosden, Soil Health Extension Educator. And Courtney's going to share a few things with us here before we get rolling.
Hi, everyone. Yeah, I just wanted to tell you again who I am. I'm taking over for Jackie. And I've been working to figure out how to share these videos and make them a little bit more accessible. So I'm going to try to share my screen here and help you navigate to them all real quick. Can you all see that?
Yep.
Okay, perfect. So I've recently made all of our virtual field day videos public so you can see them better now. So if you type in University of Idaho cows into the YouTube page, you can go there. And then you just click on any University of Idaho cows video and it'll take you to the channel or the page for cows. And then if you go to playlists, and we are now have our own full playlist under soil health. And so all of the virtual field days that Jackie and everybody else worked on when she was here are in this folder. And then also the 5 for 5s are here as well. And I'm going to get the last one posted that we did in December here. Of course, technology issues with exporting it. But yeah, that'll be on in the next few days. So you can check all of these out. And then I'll get this recording edited soon and get it on here also. And then I wanted to share where the NRCS website is too, just in case you all don't know. So if you just go to NRCS Idaho Soil Health, or actually just go to NRCS Idaho, Google that, and then go over to the side on soil health. And then there's also a way to navigate to the virtual field days to that website or to that YouTube page right here also. So I just wanted to share that with you all. Oh, actually, and then Steve and I wanted to plug another plug. Steve Schuyler and I are trying to figure out whether everybody wants to get together for the Magic Valley Forum, Soil Health Forum. So if you all are interested in that and you have any ideas, yeah, either put it in the chat today so we can kind of see whether there's interest there, or email me. I'll put my email in the chat as well. So yeah, we're just kind of trying to gauge whether we want to have that forum this winter. So that would be great. And I'll stop sharing now.
All right. Thank you, Courtney. Appreciate that. It's a nice reminder on these events are recorded and they're available, as well as the virtual field days that Jackie produced, and getting them kind of reconfigured so they're more publicly available than they were before is awesome. I know they were hard to find in the past, so hopefully that helps a few people out. I sent out a little email with kind of telling folks who was going to be with us today and what their topics were. Rob, I think I saw you log on earlier. Are you ready to go with talking about manure and other management practices for soil organic carbon?
Yep, I'm ready to go.
Awesome.
But it's after lunch, so now I'm feeling sleepy. Of course.
Maybe you can tell us what you do and where you work before you get rolling.
Yep, sure. Let me open up this screen here. Can anyone see that?
Yep, we're not in presenter mode, but I can sure see your presentation.
Okay, yeah, hi. I'm Rob Dungan, and I'm a research scientist with the USDA Agricultural Research Service in Kimberly, Idaho. And a lot of my work revolves around manure utilization in cropping systems and understanding the impact and benefits that manure utilization has. I do a lot of work with greenhouse gas emissions. I've done work on antibiotic resistance and soil health as well. And thanks again for the invite to participate. I will do my very best to keep it under 5 minutes. And I'd just like to acknowledge my colleague here, Dr. April Adom, who works and collaborates on these projects. So I thought, considering it's my first presentation with the group, and I haven't interacted with this group as of yet, I would introduce some of the long-term field projects that we have here in Kimberly. And a lot of it, as I mentioned, has manure as a treatment. And starting over here, and I think you can see my cursor, I'll present some results from our GraceNet project, which was started in 2012. It's a pretty much typical dairy forage rotation of corn, barley, and 3 years of alfalfa. We wanted to look at the effect of fall versus spring dairy manure application. We also apply fall compost. We have a fertilizer treatment and a non-fertilized control. The compost and manure applied at 25 and 52 megagrams per hectare. I'm sorry, I didn't put it in tons per acre, but if you divide it by 2, you roughly get tons per acre. Everything is under conventional tillage. Our long-term manure project over here to the right, we started in 2012 also. It's our commercial cropping rotation of wheat, potato, barley, sugar beet. We apply manure at 3 different rates on a biennial and annual basis. These are, you'll see these are fairly high manure application rates because we wanted to mimic what the producers were doing. And that's a dry weight basis. So keep that in mind. It's about 50% water moisture. So, you're looking at 100 megagrams per hectare applied. This field is also conventionally tilled. We do disking. The cover crop project is a corn triticale rotation, and the winter cover, triticale is a winter cover crop. Our treatments are strip till versus conventional till, manure versus no manure, cover crop versus no cover crop. I will mention that we originally started off with no till, but we got poor germination of the corn, so we had to go to strip till. And we're applying manure at 52 megagrams per hectare. So we use the same rate throughout all these different projects. So these are the results from the GraceNet project, and you're looking at soil organic carbon on the y-axis, and you'll see that when you're adding manure to soil, you're going to get a rapid increase of soil organic carbon. After you stop applying manure, then you start to see quite a bit of a decrease in the soil organic carbon. And once again, when you start applying manure, you get a spike in soil organic carbon. The greatest effect or response was from manure solids being applied. Fall compost did increase the soil organic carbon some over that of fertilizer. And when the fertilizer treatment, there was essentially no change in soil organic carbon over that time. And I wanted to point out that, with alfalfa in the rotation, there's some talk about using alfalfa to increase soil organic carbon. However, we have not seen that increase here in this particular field project. These are the results from the long-term manure project. And so obviously what you immediately see here is that the soil organic carbon levels are directly related to the manure application rate. So here's the high, here's the medium, here's the low manure rate. But I think what was really most interesting about this work as well was that, considering we had potato, sugar beet in this rotation, is that you can see that after we harvest the sugar beet or potato, you get this drop in the soil organic carbon level. And so, you got to keep in mind that, harvesting sugar beet and potato is quite intensive. There's no such thing as no-till with sugar beet and potato. And, it's quite destructive to the topsoil, and then exposes all the soil organic matter to decomposition by the microorganisms. Moving on to our cover crop project, we had quite a response to manure solids, and we applied manure every year here. This is 4 years of manure application, and there was a strong increase in soil organic carbon. As you can see here, right there. But interestingly, when we were under no manure, and I shouldn't say interestingly, but under no manure, we didn't have an increase in soil organic carbon. And what was interesting is that, you know, mixed in here are the results from the cover crop and strip till. And so after 4 years, there really is little to no influence of those management practices on soil organic carbon. But I'll say that, you know, it is a semi-arid agroecosystem. You know, soil organic carbon is not going to build rapidly in those soil systems. So maybe if we, you know, let it go another several years, we might see a response from strip till and cover crop. And I think, am I short on time? Am I done?
Yes, if you can wrap it up.
I'll just wrap it up. Let me just stop with that. I had one more slide, but it's not that important, and I will stop sharing at that point. Here we go.
Well, thank you so
All
much,
right.
Rob.
Yep, you're welcome.
Good deal. Yeah, so, and just to remind folks of the format, we'll proceed through our presenters, and then at the end we'll open it for discussion. So if when someone's presenting, you've got a burning question for them, please write it down and then bring it up in the discussion afterwards. And yeah, that's how we'll do it. So next up, we have, and again, thank you, Rob. Thank you, Rob. That was really good. We'll have Ryan Christensen talk to us about stripper headers. Ryan, can you share your screen with us?
Yes.
Looking good.
Okay. So I farm down in Grace, Idaho, very southeast corner of the state. And about 4 years ago, I'm good friends with Cameron Williams, my NRCS agent here. And we were out on a canoe trip with some young men, and he was telling me about the exciting world of soil health and soil conservation practices that were taking place in our valley. And it really intrigued me. And so I jumped on board. The next spring, I planted my first cover crops. I sold all of my tillage equipment, with the exception of a couple pieces of tillage equipment to prepare for potatoes. I'm a dry farmer, an irrigated farmer, wheat, potatoes, and barley mostly at the time. And bought a no-till 1890 John Deere drill and really jumped into soil health and trying to improve organic matter and, you know, reducing inputs by still maintaining my outputs. So I started, you know, always thinking outside the box. But then I started learning about stripper headers a couple years ago. It took me a couple years to convince my dad and brother that not only were we going to get outside the box, we were going to step outside of the warehouse and really start exploring how we can make this soil health, soil conservation project work. So for those who are unfamiliar with stripper headers, it does just that. Instead of a cutting action with the header, it has a header with these knives on it, as you can see here on the right-hand side. These two combines on the left are my combines cutting an irrigated field of hard white spring wheat, yield of about 110 bushels per acre. And these knives rotate as the reel of a combine normally does at a very high speed, anywhere from 500 to 800 RPM. And it only is stripping off the heads of the crop that you're harvesting. So everything else is left behind. The only thing actually getting fed into the machine are the heads or the pods if you're cutting flax, which we have, or mustard, or other whatever crop you're cutting. And so that's how a stripper header works. Now in agriculture, many of you, all of you will know that there's no such thing as a silver bullet. Everything has its advantages and disadvantages, and you have to weigh these advantages and disadvantages to make it so it's profitable in your operation. And so these are some of the advantages and disadvantages of stripper headers. The first one that's the most obvious when you see one of these operating in the field is the harvesting speeds. That picture of that 110 bushel hard white spring wheat, we were harvesting at about 5 to 6 miles an hour. And with a conventional header, you're only looking at about maybe 2 miles an hour. So you're more than doubling your harvesting speed. In dry farm, when you're in the 40 to 50 bushel range, you're up into the 8-9 miles an hour of harvesting speed. The reason for the faster harvesting speed is you're only taking in the heads. So the material going into the combine is so much less. So you can thresh it cleaner, which is another advantage, and far less wear and tear on your combine. You're not putting so much material, you're not wearing out the insides of the combine, the header parts, which are immediate cost advantages to a stripper header. Now, as far as the soil health benefits to a stripper header, all the straw stays standing. And so it makes planting into stripper stubble so much better and so much easier. It's the kind of the pencil effect. You know, if you get a small little golf course pencil, it's a lot harder to break. But if you have a long branding out of the box pencil, you can break those all day. The same thing applies with stripper stubble. Because the stubble that's left is so much longer, it cuts so much easier. So you're not getting that residue pushed into the furrow, and you're getting a much better soil to seed contact than you would with a conventional header. Another advantage is no wait time to start planting. I have a picture in the next slide that I'll show you about that. You know, as soon as the combines start, you can start planting a cover crop or a fall crop. And that really helps by getting, you know, I've tried cover crops with flying it on with a plane. I've tried planting it after harvest. I've planted it in the spring, and I've never had a really good stand or a really good emergence that way. But with the stripper stubble, I've had the drill literally right behind the combine and had much faster emergence and much easier, quicker and emergence. And then snow capture. With this taller stubble, you're catching so much more snow, which leads to more water, which is going to play huge dividends in dry farm. Now, they're not without their disadvantages. If you have to do field prep behind them, it can be a challenge. We do potatoes. Our stubble got rained on significantly in October. So when it came time to put potato beds in for the fall, it took a couple times of working the soil to get that stubble broken in. It's a learning curve. You can't just jump into it and send somebody out. It's you have to take time and learn and be willing to ask questions and find people that have the answers. And so it's definitely a learning curve. And, you know, potential for slower melt off in the spring. I've got some soil sensors in some fields that are comparing bare soil following potatoes and a winter wheat planted into stubble. And I'll see how that goes this spring. And then one of those is you have to be able to withstand neighbor ridicule, because everyone's going to think you're crazy by leaving all that stubble and not having that good black soil turned under in the fall and in the spring. So this was my cover crop this year. As you can see on the left-hand side, I have my 1890 drill planting in the exact same field as my 2 combines, running the stripper headers. So August 28th of 2021, I planted my cover crop mix. This is going to be planted into potatoes next spring. So I like a green manure crop in the ground before potatoes. And then this was September 3rd. I went out with a shovel just to see how things were coming. Not only were things had sprouted, but they were almost to emerge. You can see all of these little seedlings about to break through. So 7 days from planting to emergence on a cover crop, which on my operation in Grace is unheard of. So many more heat units that way. Then this is snow capture. So this was on January 12th of this year. I went out with just a yardstick and stuck it in the ground in a few different fields. This one on the far left was a conventional header before my 2 stripper headers showed up. 115 bushel acre wheat crop. So the stubble was left at a regular height, 6-7 inches. It was baled and hauled off. 11 inches of snow. I went less than a quarter mile down the road, exact same type of wheat, exact same plant date, 2 days later harvest, 114 bushels, so similar yields, but with the stripper taller stubble and had 6 more inches of snow. I went a quarter of a mile in the other direction on a field following potatoes, so bare soil, only 9 inches. I went to a different part of my farm. This picture, second from the right, was a 8-bushel dry farm. Dry farm was horrible this last year due to the drought. But even with an 8-bushel dry farm barley crop, I was able to capture 7 inches of snow in that stubble, where less than a quarter mile down the road, and a neighbor who had conventional summer fallow, I had to find an inch and 3/4 of snow. And that was in his deepest spot of his field. Most of the ridges were bare. And so that really equates and shows you the snow capture that's available with stripper headers. And I'm probably out of time, but real quick, Cam Williams went out this week with a device to measure moisture content in the snow. And the stripper header moisture content was anywhere from 3/4 to 1.25 inches more water in this captured snow, which 25% more water, or 10% for an entire year. So I'm on board, and I'm looking forward to going forth with the stripper headers. Thanks for this opportunity.
Wow, thank you, Ryan. That was great. There's pretty dramatic difference on the snow there. We'll have to talk about that more in a little bit. Really great presentation. Marlon, we need to queue up your presentation on rhizophagy. And I'll let you, if a plant is stationary, how does it get its nutrients is kind of where we're coming from on that. And I'll let you explain rhizophagy.
Is it showing my screen, Sean? Oh, no, wait a minute. Shit. There it goes.
Looks like it's starting. I can see your computer screen with Ori and the grandkid and your trout.
There we go. I'll move it over here.
There we go.
How about that, Sean?
I'm I'm just seeing you. I think you got a screen switch.
I just lost it. Just a minute.
Yeah, if you do the share screen, you should be able to just select your PowerPoint. It should be one of the options that pops up.
Marlon, you lost it a long time ago.
Yeah, man, it's a slick. Now are you seeing my screen?
Yes, it's in presentation mode and everything. Awesome. I think we're there.
My question to the audience, well, first of all, Marlon Winger with NRCS Soil Health Division. I work with Idaho, Montana, Utah, and Wyoming, and have missed traveling for about 2 years. So it's been a tough 2 years for a person that likes to hear themselves talk a lot. So my question to you good folks that's listening to the presentation, if a plant is stationary in the ground or in a rock, and we've all driven through the mountains or whatever, how does those trees growing in the rock get nutrients? That's always perplexed my mind, but I was never smart enough to think about it until this last 6 or 8, 10 months ago. I've started learning about a concept called rhizophagy, and that's what I want to talk about. This research is done by James White and a whole host of undergraduate students and some people that work, I think in Japan, who first published this rhizophagy concept. If a plant is stationary in the ground, how does it get nutrients? Well, we learned in about 2nd grade that plants have roots and they explore the soil. That was a pretty cool concept that we learned in 2nd grade. When we're 10 years ago or so, most of us learned about arbuscular mycorrhizal fungus. That's the 2nd picture on the right. And that was kind of a breakthrough for me. I remember the day I learned about mycorrhizal fungus. It's like, wow, a plant shares some of its photosynthesis, sugars and exudates with a mycorrhizal fungus. And so that was pretty cool. The other way, the plant hopes the farmer writes a great big check to supply whatever it needs for fertility. The other thing a plant hopes is the farmer uses the 5 principles of soil health to get the nutrients it needs. The nutrients are in the soil, but often not in reach of the plant or in plant available form. And so that plant has to work with its microbe partners to help make those nutrients available. So I want to talk about rhizophagy. Rhizo means root, phagy means eat. So the concept I'm going to teach you today from Dr. White is that plants farm soil biology, such as bacteria and fungus, etc. What they're finding out is all plants do this rhizophagy cycle, not just a few of them, but all of them. So just in a nutshell, plants are managing soil microbes. These plants attract, the microbes are attracted to the roots. The plants internalize them, and then they use reactive oxygen to extract the nutrients from them. That's kind of a one-sentence synopsis of rhizophagy. So in the field, we often, when I go to the field and Cameron Williams, we're digging up plants, for example, Sean, we're looking at the rhizosheath and we're learning about rhizosheath. Well, after learning about rhizophagy, I thought, oh my goodness, here's a process that's going on in the rhizosheath. And so picture A is just kind of a internet picture of a wheat seedling that shows a really good rhizosheath, complete rhizosheath, has a thick rhizosheath diameter. That's the region of soil right around the root. Picture B is a plant that's not quite as happy. It kind of has an incomplete rhizosheath. It has, where it's measurable, has a thin rhizosheath diameter. So anyway, just kind of a concept that I've looked at when I'm looking at a rhizosheath. Now I'm thinking, oh boy, now rhizophagy cycle is occurring. Here's a one of the many pictures from Dr. James White on his YouTube videos, and I was just watching one yesterday, a brand new one he released, and he's got just a ton more information in his new talks compared to 3 months ago. So this is a plant root showing its plant hairs coming out. And just briefly, I love this slide because the concept is step one, the bacteria or microbes enter the root at the root tip or a few other places near the root tip. Step two is the plant extracts nutrients from the bacteria. So they strip the nutrients off the cell wall of these bacteria, for example. Step three, step two, I got to say, while the bacteria are inside the root cellular tissue, they're not dead, they're alive, they're growing, they're reproducing, and it's pretty technical, but at a certain point in time, the bacteria then are stripped of their nutrients, and the live bacteria actually exit. I'm sure there's probably some dead bacteria also, but the bacteria exit through the tip of the root hairs, and I'll show you a cool picture of that coming up. Step four, the bacteria are recharged with nutrients. So they're spit out of the root, they're recharged with nutrients, they start breaking down organic matter, mineral rock, whatever they're eating, they're fed root exudates, of course, and then the cycle starts again. So here's the powerful, Sean, is my whole screen showing, or is it showing part of the Zoom thing?
I can see your whole screen, Marlon.
Okay, all right. So in his talk, he shows this cool diagram, and it kind of helps me understand it a little better. So we'll start down here at the bottom, wherever my mouse is. The microbes the bacteria are rod shaped. Generally, they're mature. They have a cell wall, a membrane on them. They enter through the root tip and in regions really close to the root tip. The interesting thing is James White says they don't quite understand the mechanism how these microbes get into the root. If they're sucked in, if they move in because it's a food source and just get absorbed. But anyway, they actively move into the root. While they're in the root, they continue to reproduce and grow. And then at a certain point of time, the plant root hits them with a shot of reactive oxygen. Now, I didn't know what reactive oxygen meant, but it's kind of like a hydrogen peroxide, where it will strip, that reactive oxygen will strip off the cell wall or the cell membrane. Then after that process, the injured, I guess you could say, the injured microbes are spit out of or exited through root hairs, and they are pretty well exhausted of nutrients. The microbes go back into the rhizosphere area, they're recharged with nutrients, and the cycle starts again. So here's one of Dr. White's pictures of a little root hair, and look at all of the microbes associated. These are all the little scattering, the little blue dots. These are all microbes around that plant root, cycling through that root system. Here's some cool pictures of bacteria with cell walls. You can see the cell walls. You can also see bacteria multiplying. They're doubling, in a sense, if that's the correct word. And now generally these are pictures that would be outside of the plant root. And then they're sucked into the plant and they continue to multiply and grow. And then at some point in time, they're hit with reactive oxygen, a superoxide, they call it. And then inside the plant, they change form. They become protoplastic. Maybe that's not the correct word, but they're formed into circles, not rod shaped anymore. They're called protoplasts because they're protoplasts because the reactive oxygen has stripped off their membrane where the nutrients are. So that's part of the process. Now, this is something I've never seen, nor did I know happen until a couple months ago. But this is a little video clip, and I can't show you the video because I don't have the video. But the arrows are pointing to these protoplast cells that are being pushed out of the root tip. You can see up here in number 1, through cellular fluid movement in the root, the bacteria cells in this scenario are being pushed or congregated to the root tip, these protoplasts. And then the video shows them pushed out, I don't know, kind of like pinching a zit on your cheek. So they're being expelled out of the system. A couple things I thought that was interesting in his talk, winding down here quickly, is that they tested plants, seedlings with no bacteria. So they sterilized, killed all the microbes. And then they evaluated 2 or 3 strains, and then analyzed the wheat shoot for the wheat leaf for nitrogen content. And those plants that had microbial association had about 30% more nitrogen. And the same thing on phosphorus. Those that have interaction with microorganisms had about 20% more phosphorus in their root tissue. He also shows the same thing with potassium. Now, what they did in potassium this last project was, again, no bacteria on the left, and strain 1, strain 2, and strain 3. And they noticed that bacteria strain 1, basically tripled the amount of potassium. So my question to my own self was, wow, isn't diversity important to a biological system? In conclusion, plants are farming microbes in the soil. This is how they naturally get nutrients from the soil. So this is kind of a why talk. It's not really a how talk, but it's a why. Seeds carry microbes, so treating seeds put them at a disadvantage very early on. Stop deep tillage. The deeper the soil you go, the less microorganisms are in that deeper soil. Dr. White is very adamant about we should be looking to improve crop management to support microbial growth. And how do we do that? Most of us realize that we do that by implementing the 5 principles of soil health. And the YouTube video that I watched yesterday and this morning is this bottom one. But if you just YouTube Rhizophagy, you'll see Dr. James White all over the internet. So to me, was a really awesome speaker of how the plant functions with the microbe. And I'll leave it at that, Sean.
Awesome, Marlon. Thanks for that. Yeah, that's kind of some mind-blowing stuff. It appears the plant has some capability of feeding itself. I'm sure there's going to be a few questions on that, and you might be getting some in the chat as well. So thank you for that. And up next we have Jenifer Krecker-Yost talking about active carbon, the new soil health metric for southern Idaho. And I'll let Jenifer introduce herself. She's helping us with putting on the Zoom today. So take it away, Jenifer. I can see your screen just fine.
Yeah, awesome. Thank you, Sean. So I'm Jenifer Yost. I'm currently Linda's postdoc. She unfortunately was unable to present herself today. But today I'm going to briefly be talking to you about a project we're doing in collaboration with amalgamated sugar to use active carbon as kind of this quote unquote new soil health metric for southern Idaho. So if you don't know what active carbon is, it's also known as POC, which is permanganate oxidizable carbon. And active carbon is essentially just the carbon pool that's readily degradable by microorganisms. So this is a very quick and easy food source for the microbes. And there have been some studies on active carbon, primarily due to the fact that active carbon is very sensitive to management practices, especially when you're comparing it to organic carbon or organic matter, which especially in southern Idaho takes a really long time to kind of build up. So this is a graph looking at the active carbon on the y-axis, and then you have your organic matter content on the x. And for here, you can see that when you just increase your organic matter ever so slightly, you see that there's a giant increase in the amount of active carbon that's in the top 6 inches of the soil. So although it takes a really long time for organic matter to build up, management practices really influence how much active carbon there is in the soil. So you measure active carbon by color. So this is what just 4 samples that we took a picture of look like during the extractions. And usually when you think about how concentrated a specific thing is, when you do a water extraction, you expect it to be a darker color the more concentrated it is. And for epoxy, it's actually the opposite. So the lighter the color for these extractions, the more carbon there actually is in the soil. So for example, you can see that when you have a conventional tillage practice with no compost added, the color of the solution is very dark, meaning that there's just a little bit of carbon in those samples. When you compare it to a strip till soil with compost additions, you can tell not only is the concentration higher, but the color of the solution is also a lot clearer and less pink. So I'm going to be sharing results that we collected last year from 145 fields that were going into sugar beets in the Mini Kaja and Twin Falls region. We looked at these based off of different tillage treatments, different irrigation types, and whether compost or manure were added or if crop residue was left prior to planting. So this is the graph showing for the different tillage treatments. They're a box plot. So the wider the box is, it just means the more variation there is within that treatment. The narrower the graph or the narrower the box, the less variation there is in those samples. And for here you can, and the N stands for the number of fields that were collected. So there we had 95 samples under conventional, 40 under a reduced tillage practice, and then only 10 were under direct seed or no-till. And for here, you can see that at least under the fields going into sugar beets, the active carbon content is a lot higher in the reduced tillage, and that's more than likely due to there being less disturbance in the topsoil. Usually microbes are not a huge fan of just soil disturbance. So you can tell that their carbon levels are much higher under a strip till or reduced tillage practice. For irrigation, we compare the differences between a pivot, a center pivot versus a wheel line. And for here, you can see that the pivot irrigation tended to have higher active carbon levels compared to the wheel line. And our hypothesis for that is that a center pivot is able to go over or is able to irrigate the soil a lot faster than a wheel line. So we're anticipating there to be a little bit higher soil moisture in center pivot fields in comparison to the wheel line, since microbes have kind of this water content, which makes them kind of the most happiest. And if it gets too dry, then the microbes aren't going to be as active as in a wetter environment. When looking at dairy manure or compost additions, as you can see, we only have about 31 fields last year that had an addition of manure or compost, but you can see overall that when you add manure or compost, you should have a lot more active carbon in the topsoil. And similar when you look at your residue, and this is residue in tons, typically when you have more residue left on the field prior to planting, you're also going to start out with a much higher active carbon levels at the beginning of your field season. So these are just some of the results that we got last year. We're going to be collecting another, I think, 200 to 400 samples this upcoming spring from fields that are going into sugar beet. And one of the things we're super interested in doing is being able to come up with a field method. So that way, whether there's whether crop consultants want to go out to a farmer's field or during university or ARS field days, you can take this instrument right here, which is a colorimeter. It's handheld, it can go out into the field, and you can really tell not only based off of the color of the solution, how much carbon there is, but you'll also be able to see an actual value. So that would be good, especially if you're at a demonstration plot, of being able to see kind of the differences in person of what might be a healthier soil compared to the other. But besides that, that's all I have today. I'd be happy to ask or answer any questions that you may have about this project.
Awesome. Thank you. Thanks, Jenifer. That's some great stuff. I think that could be highly useful, and it's needed. So awesome presentation. Brad, we've got you lined up to share with us some soil health podcasts that we should be putting on our radar.
Yep, I suppose so. All right. Screen to share. Come on. There we go. Everybody see that all right?
I see your presentation. It's not in presenter mode, but I see it just fine.
Should be.
There we go. You got it.
Okay. You're not seeing all my notes and everything, are you?
Nope.
Okay. All right. So, yep, I'm switching it up a bit today from actual practices to information gathering. I'm Brad Johnson, work for the Nature Conservancy in Idaho, and assist farmers in implementing soil health regenerative ag practices. I won't go into my background since I think a lot of you have heard from me once or twice already. Podcasts, some of you probably listen to them already, somebody maybe not. But these are a great way to gain information, build excitement within yourself, and they can change your mindset. I thought it'd be a good thing to share some of my favorites. I listen to podcasts most of the time while I'm driving. Used to listen to radio, but now I'm kind of into these. Even listen to 1 or 2 a day while we were digging potatoes in Rexburg this fall, either through the radio in my pickup or with earbuds in the tractor. Most of these podcasts that I'll share are corn and soybean country, but the principles are the same wherever you are. We just have to adapt the ideas to our area. So this first one here is by far my favorite one. It kind of blows my mind a little bit, like Marlon's talk just did. It really challenges the way we think about crop production and plant nutrition. I do have to say that I am not trying to sell you on the products that are advertised in these podcasts. I'm not promoting this business. I'm just only speaking to you about the podcast and the ideas that they talk about in their podcast. Anyway, it's Regenerative Agriculture Podcast. John Kemp founded a company named Advancing Eco Agriculture when on his own farm he struggled to increase his yield while still using tried and true plant health techniques. So he started to study different approaches, and this is kind of what he found. In my opinion, John's knowledge and expertise in regenerative agriculture is second to none, and the way he interviews people is amazing. It's thought-provoking and inspiring. One of his specific episodes that I love is episode number 77, where he interviews Rick Clark. For those of you who haven't heard of Rick Clark, he's a farmer in Indiana that has implemented soil health on around 7,000 acres. But the first episode I ever listened to was number 75, a farmer from New Mexico and his journey into soil health. This producer has transformed his farm in a way that he's almost doubled his cotton yields while simultaneously decreasing his per acre costs. It was kind of fascinating to hear his ideas and why he's jumping into soil health and regenerative ag. That one's the one that got me totally hooked on Regenerative Ag Podcast. It's a good one. The next one, Soil Works. This podcast, they're shorter episodes, which is nice. The Regen Ag are over an hour most of the time. But Soil Works, they're shorter. They're a little more cheesy. The guy that is always interviewed, I don't know, he's kind of tough to listen to sometimes, but his ideas are totally worth listening to. This podcast looks into the causes of different issues we face in the farm. For every weed issue we face, there's a reason for that, whether that's a nutrient that is out of balance or some other soil biology factor. For example, one episode is about nitrogen and why we may be showing a deficiency, even though we applied the correct amount of N to our fields according to the soil test report. There's probably another reason in your soil that your N is short in your crop. Like yield loss always has a cause. We should look at what caused that symptom instead of just trying to fix that symptom like we always do so many times. That's another good one that I like. Soil Sense is a good one. It's done by the North Dakota State University. And North Dakota is a state that has had great adoption of soil health practices. Tim Hammerich is the host. He interviews growers and other people in North Dakota that are implementing practices, mostly corn and soybeans again, but there are some episodes with dry land and irrigated wheat and some with cattle. This one's just a good way to learn about how other farmers are implementing soil health practices, why they feel it's important, and how it's impacting their farming operation. So those are some of my favorite ones. Some other noteworthy podcasts are the People of Soil Health. It was done by the Soil Health Partnership, which is now gone. They were funded by the National Corn Growers, and they are no longer operating, but the podcasts are still available. No-Till Farmer Podcast. It's mainly all no-till, some cover crop stuff. And it's a good one if you're looking at no-till and just if you maybe have something you're struggling with, there may be a podcast in there with the answer. Cover Crop Strategies is an older one. It's actually now done by No-Till Farmer. And it's 100% cover crops. How to grow them, what works, what cover crop does what for you, and how do you form your goals that you want out of your cover crop, which cover crop can meet those goals. Now I've gotten lost in my notes. Personally, I've learned a lot from all of these podcasts. One of the big things to me is hearing why these farmers went down the soil health regen ag path. There are lots of different but very similar reasons. I know NRCS has a podcast that they do. I don't think it's out of Idaho. The Minokan Farm is another good one. I didn't list that one on here and I should have. But anyway, I listen to these on Spotify mostly, sometimes with the podcast app on my iPhone. If you're a farmer or industry person, somebody that's interested in soil health and you're driving down the road, just pull one up on Bluetooth if you have Bluetooth in your pickup. When I was in the tractor, I used earbuds. I could still hear the equipment working and I could still hear the podcast. So it worked really well. So That's all I've got for you today. It's kind of short, but thanks for listening, and I hope we have a great growing season this year.
Awesome. Thanks, Brad. Can I talk you into pasting those, or maybe you already did copy and paste those into the chat?
Yeah, I can
those
try to do this.
Yeah, that would be great. Lots of good information out there. All right. Hey, the next thing that we've got set up here is to talk a little bit about a scenario that one of the folks that we've worked with has got going on. So the basic title of this is Control of Common Mallow and Soil Health Concerns. And this this scenario is something that Barry Duelke's working with or dealing with, and I'd like to see if we can hear from Barry. He's called in today, and if he could describe the scenario that he's got with the mallow and what he's considering for options for treatment, that would be great. Well, I'll do what I can to share this scenario, and I think there might be a few other folks on the call that have talked to Barry about this. Barry manages his land for forage. He's got a sheep operation. I think he's managed cover crops under pivot for sheep for several years, and I don't know that he even uses BLM allotments anymore. At any rate, he's been very successful in what he's done. High organic matter percentages on his place, 5 to 7% organic matter. Soil function is outstanding. Infiltrates all the water you can give it, etc. At any rate, there are a few areas where he's experiencing common mallow being the dominant thing.
Sean,
and,
I'm online
yes.
if you can hear me.
Oh, yes, sir. You just came on.
Well,
Hey,
I got it somewhat figured out. Okay, and I missed what your comments are, but I'll go ahead and start if you want me to.
Yeah, you bet. I gave him just a little bit of background on your.
Okay. All right. Well, I'll run right through it.
Okay. All right.
Okay. I'm really grateful not only for Marlon but Brad and Jenifer, because all of those things impact this decision I'm trying to make. Teaming with Microbes by Jeff Lowenfels is a very good read on the basics of the food web. And I'm in the middle of that. That's very informative. The regenerative agriculture I've kind of done almost by default with grazing management. And Brad, if you'll pull up Dave Scott out of Whitehall, Montana, and his podcasts on regenerative grazing, he's producing 7 ton to the acre pasture grass and forage without any fertilizer. Dave Scott, and very, very good stuff. And so I am sitting in a situation where I'm no longer in the range business where we used to come home and feed a couple thousand ewes on 20 acres, give or take, off the side of the lambing sheds. And then for 8 years, I would plant that to spring cover crops of cereals, brassicas, Italian ryegrass, and sequentially graze that from July to October. In doing that, and it is under pivot, and it was a minimum till, just scratch it with a chisel plow with points, roll over it with a roller harrow and plant, because the residue was heavy from feeding. The last couple of 3 years, I have an encroachment of common mallow, which has gotten stronger and stronger and more competitive. Now I wish to plant that to a mix of perennial cool season grasses, forbs, and legumes this coming spring and April. And I don't want the competition from the common mallow with the seedings, etc. And I want to try and get a successful seeding. This field, is a 5-7 organic, 21 CEC, 120 units of organic nitrogen, 80 phosphorus, 889 potassium. It is nutrient loaded. It's rich. It's got buckets full of earthworms. And I want to turn it into a rotationally grazed cool season pasture and not have to spend the money, go to the effort, and then have an unsuccessful seeding. So my question and dilemma has been, which does the most damage to the microbiome, limited tillage or an application of Roundup, which may not even be the perfect herbicide. Sharpen is registered, but it also has planting restrictions after that in legumes, which wouldn't fit. So that's my question that I'm trying to answer to make a decision. What will I do to give myself a clean seed bed without destroying all these things that you guys have talked about that are working for me down there? I do not, and probably have, that's not that I'm organic, I'm not. I haven't essentially bought fertilizer in 8 years. And I'm under pivot and things, I've got these cycles going. I want to maintain them and not destroy them intentionally. That's the question. I'm looking for any feedback, anybody with experience with it, opinions, directions, that I can gather as much information possible before I have to make a choice.
I think that's an excellent description of the scenario, and this is probably a great way to kick off the discussion portion of our meeting here today. I think Barry would welcome anyone chiming in on what they think might be a good way to go with that, and particularly if anybody's got any experience with mallow and specifically, that would be awesome.
And appreciated.
Yeah, I haven't had much experience with mallow other than spraying it, but what I was going to offer up is TNC's working with this Advancing Eco Agriculture, John Kempf, a little bit, and I will ask his consultants if they know of any nutrient ratios or anything in the soil that could be off that mallow would favor, and maybe you could help your mallow problem that way.
Yeah, I did get some feedback out of Kentucky that suggested compaction because they had a similar issue where they wintered and fed cattle.
Okay.
And since we used to drive over this with tractors and trailers and ton bales for years and years, and I would tickle this thing basically 3 or 4 inches to break any compaction and then plant, and I get good cover crop feeds, lots of production, but that could be an issue farther down. It hasn't been plowed. I never mow board. I've been chisel plowing all my life, and it's never been any deeper than 3 or 4 inches for 8 years. And that was just to help disturb and I have a no-till drill, so I can do that if I need to. I can clean up this seed bed.
That mallow plant's kind of a tough customer, isn't it? I mean, it's a tap.
Oh, I got some that have got a root as big as my thumb.
Yeah, it's a tap.
It is the least palatable thing. The sheep, and I'm a sheep herder. I'm usually the only one here. They eat everything else first because everything else is more palatable. And they will ultimately, and in my permanent pastures, mallow is not an issue because they keep it in check and the competition from the other portions of that pasture in this regenerative deal. And so we go in, we're getting away from the Allen Savory, keep it vegetative. We go in when it's ripe and start eating that because it just gets away from me. Now I'm understocked, but you know, we're putting a lot of residue on the ground, and you don't get to a 5-7 organic matter unless you put a lot of trash back on the ground. These fields have not been harvested in any other way but grazed out for 8 years.
Marlon, did you have any ideas on the mallow? I mean, it's a tough customer of a plant. Taproot sets seed multiple times a year. That's really persistent.
Spring and fall.
I'll share a little bit. One of the challenges you have, there's 56 people on the call, and Barry, you probably have 56 different opinions of how to do it. And so good luck sorting that out.
Been there already, Marlon. Yeah, but
good luck on sorting that out. I'll share you my opinion, which is worth about 27 cents. It has gone up from 25. I think you got to look at your weed and say, how do I beat it? I gotta do things different based on the weed. So if your mallow generally germinates in the spring, you got to realize that. So one of the ways to beat it is to plant your crop or your pasture in the fall time so that you are different 180 degrees from when it's most competitive as a when it's dropping seed and germinating seeds, not dropping seeds. So my recommendation, if this was and I haven't seen the field, I haven't dug a hole and seen how severe your compaction is, but my suggestion would be to plant a spring cereal forage crop, an oat, barley, wheat, spring, something you could cut for hay or graze, whatever. But it gives you an opportunity to spray with an appropriate labeled herbicide that claims control of the mallow. So if Roundup on the label doesn't claim to control it, don't spray it with mallow. With Roundup, you got to find a herbicide that claims control. So you have a competitive crop, then you have a herbicide. Then you make the decision if you're ready to plant, this coming fall, your pasture, and maybe that is an opportunity to no-till drill into that stubble, so that you don't bring up all those weed seeds. That's one of your challenges. Every time you till, you bring up 50,000 weed seeds per square foot instead of leaving them buried, the ones that are buried. If you don't plant your pasture, plant another fall small grain that you can spray a broadleaf herbicide on, and then it gives you an opportunity to spray again in the next coming, April or May, as that cereal grain is 4 to 6 inches tall. Spray with the herbicide, knock out the common mallow, and keep it from seeding. And then you look at seeding your pasture in the fall, that coming fall. So I hope I probably confused you at a higher level, but if you're interested in me slowing down and talking, maybe we can talk on the phone a little better. But that's my 27 cents worth of agronomics.
I appreciate that, Marlon. No, it's not confused me. I've been after this for months. I would tickle this ground with points. I even took my twist shovels off to try to minimize tillage years ago. But I'm about to the point where I will put 14-inch sweeps with a point in front and pull that down through there and prune it like we used to control alfalfa and start off with a new crop. But that's going to be some pretty severe tillage.
Yeah,
but that will help control it, because my moldboard plow, my neighbors that row crop, they don't have any trouble with it. They don't even know. They say it's a tough one to get to, but they don't have any trouble with it because they prune it off every year.
Most of the literature says that mallow is an annual or a biennial.
It's a biennial, yeah.
Yeah, it's biennial, so it lives 2 years, develops a big old root.
And that's right. That's exactly what it took.
Yeah, and you probably cannot control mallow in its second year with a herbicide. It's too big. It's probably too big. You could probably only control it when it's a seedling.
I agree, and I keep coming back to the tillage, and particularly with the sweeps and going a little deeper, even 5 inches. I got neighbors that suggest 5 inches. The extent of the damage, and Sean and I have talked about this, and let the soil reset was his comment. And that may be the most appropriate. There again, I'm not organic, but the most appropriate, because I do get some tillage in it each year, and it produces, and it's continued to improve. I'm not so sure it's just not time to just say, let's do the tillage, accept the damage, and move on.
And the only reason you need to do the tillage is to control that second year.
I want a clean seed. Nope, I want a clean seed bed. Once it takes a year to establish. And like we were talking earlier, even the grasses, a lot of them are $5 a pound with freight, plus all the other ingredients. You can get some money out there. It's not a lot of acreage. But the other aspect of this is I am planting 3 different mixes, because these fields are adjacent but separate, where we used to feed and divide up livestock. So I'm planting 3 different combinations, and primarily the difference is the grasses, to see which one will be more appropriate, more productive, because I'm an orchard grass base, have been that way for decades, and it just takes over. I'd like to be able to maintain the diversity, which I am losing over time because the orchard ground, other issues, and that's another issue, and that it affects, I think, my animal performance and you get the cool midsummer slump, and your gain can drop by 2/3 of a pound per head per day. That's how I make a living. So there's a
Hey,
lot
Mark.
of questions rolled into one.
It's a lot of stuff to consider all in one go. With that one scenario, it makes an awesome discussion topic. It really does.
I don't want to
appreciate you.
dominate the discussion. We'll move on. You guys, please, I don't need to tie the whole thing up.
Well, I think we just say discussion's completely open for anyone that's got comments or questions for any of the presenters. But that's a great talk about,
It's a real life
mechanical
situation.
disturbance. Yeah, mechanical disturbance versus chemical disturbance, timing, particular problem plant. It's a lot of good stuff all in one spot.
Thank you.
I had a question for you, Barry. I appreciate you being on. I had a question for Ryan that I wrote down when he was talking about that snow capture. By the ruler, it seemed like it should. I mean, it's pretty dramatic, the difference in the where you got the tall straw standing. Is it real obvious from the road? Can you tell the difference? And are you getting any questions or your neighbors noticing?
It's not as apparent from the road, but as soon as you walk out into it, it is. And the dry farm is very apparent, because around here, even places where I put potato beds, you're starting to see, before last week, before the last little snow, you were starting to see some bare dirt, where mine, it hasn't really dropped much. And so it really depends on if it's bare soil versus stubble, but the conventional stubble versus the stripper, it's not as a stark difference.
Well, I wonder if that difference will be more apparent come spring. We see how things take off. That soil moisture ought to make a nice difference for you, I would think.
Yeah, I mean, we're about 12 inches of annual rainfall, 11 to 12, and so to get an extra inch in the wintertime is gonna be pretty big, I think.
Hey, Sean, I got a question for Ryan. Ryan, tell us about your fuel efficiency, if that changed at all. And so you bought your first stripper header. What made you buy your second one?
So we bought 2 combines to start this year, and I convinced my dad to buy 1 stripper header, and he did not like the idea. My dad's like semi-retired, about 80% retired, but at harvest time, he's 100% here. And he wasn't wild on the stripper header. And so he's like, we better keep all our others. And when he ran the stripper header for about a half a day, and he was on the phone with me saying, hey, you got to find us a second one. So I found a second one, and it was here within about 4 days. And so that's what led to the second one. And, prior to this year, we also have a swather. So we've swathed grain, we've had conventional headers, we've conventional cut, and now stripped. And there really it's no comparison on which ones are best to drill into, and the cleanliness of the sample as well. As far as fuel savings, we saved about 65% in fuel. So about 45% of the fuel that we normally use is all we used this year with stripper headers. Previously, running a 42-foot conventional header, we were filling the combine every day. Sometimes, if we ran a long 16, 17-hour day, it was refill before it got dark. And the stripper headers, we were filling up about every other day, and cutting the same amount of acres. So fuel savings was really huge.
That alone will pay for the headers within a few years.
Oh, absolutely. Yes, you're looking at probably a good 700 to 1,000 gallons less per combine. So yeah.
And then after those few years, then you're getting return on investment that looks pretty good. That's awesome.
Exactly. Now the parts they're a little bit more maintenance. The knives have to be replaced and are a little bit more expensive than a conventional knife section. But you're gonna make up for what you pay in the header. You'll more than make up for what comes out in the main machine, just from the lack of material going through it.
Yeah, I've got a question for Marlon about the workings of rhizophagy. Marlon, is there any indication with that rhizophagy is only active in certain plants or at certain times? Or what plants do they look at, and is it timing dependent?
That's a good question, Sean. That kind of blew me away, because we used to always hear, oh, Kentucky 31, Kentucky bluegrass had a fungus that grew in it, and it was maybe for plant health, and it reduced palatability. Dr. White says all plants have endophytes, meaning that all plants have this rhizophagy cycle going. And it's crazy when you listen to his talk. He works in cactus and marijuana and different crops and trees, and it's just wild. So, when I listened to him, I thought, boy, that'd be a fun technical plant biology talk to invite him to Idaho some year down the future when COVID relaxes. Just a mind-blowing new area that we've never even developed before. In fact, it's so mind-blowing today. This morning I finished his YouTube video. He says that trichomes on plant hairs, right? Like sting and nettle, you touch sting and nettle, it makes you itch. Well, he says the trichomes on plants fix atmospheric nitrogen.
Wow.
And it's like, wow, we are learning so fast. And anyway, that's what I learned this morning, that plant hairs fix atmospheric nitrogen because it's the biology in those plant tips of those plant hairs. But anyway, you got to listen to him yourself. I probably butchered his talk after you listen to it, but he's a brilliant person.
Well, no, I thought you did it justice, particularly given the short time frame, and yeah, it reminds me of how little we know about how it all works. It also reminds me of that paper by Franz Lubers here recently that in the last couple of years, where they related increased microbial biomass to a decreased need for nitrogen fertilizer, and that's a mind-blowing paper too. Hey, so I want to ask Jenifer a question about the active carbon. How ready for prime time do you think active carbon is as a kind of a standard soil health assessment tool?
Well, so far, based off of what we've been doing out here, which for me has been a lot of soil physical properties, it seems as though active carbon is a really good metric out here. It is at least very sensitive in the 145 fields we've looked at. We're right now kind of trying to see if it links up with sugar beet yields at all or sugar content, but it's still relatively new, and I know it's something that Linda and I are excited to continue working on this year and hopefully next as well. But it's a really quick and easy measurement. Once we have the field protocol put together, we can get results within 15 minutes. So we really wanted to find something that was fast and easy that we can do at a field day to kind of show off whether or not a specific management practice is good. We also want to come up with some sort of a soil health index too, based on this measurement, but that still has a bit of work to go before we can say if you have this number, you're doing fairly well, or if you have a really low number, maybe it's time to switch up some of your management practices for your field. But so far it seems to be a very promising metric, especially out in Magic Valley. I don't know if Rob has anything he would want to add to it. 'Cause I know he is also doing some epoxy work on his ARS plots. Yeah.
Yeah, you know, because we have manure, everything is driven by the manure. And you do see that direct relationship between POC concentration and manure application rate. And it can be a little bit misleading because, you know, you're going to think, wow, I have great soil health, but at the same time, some folks are over applying manure and you have other problems associated with over application of manure. So there's got to be some type of balance, and maybe we can wade through the minutia here with all the data that Jenifer is collecting.
I was going to ask you, Rob, on the this study you presented. We were looking at a graph that was indicating changes in soil organic carbon over time with different treatments, and like strip till and cover crops without the manure, we're showing a slight increase, but perhaps not significant. I was wondering about how that soil behaved. If it was being subject to a lot less disturbance and it had a living root in the ground the majority of the year. And I didn't ask you what the cover crop mix was, but I mean, just considering those two things, minimize disturbance and increased time with living roots in the ground. Did it take on water better? Did it behave differently? Is that soil perform differently than the one that's conventional right next door?
Yeah, I mean, you can actually ask Jenifer that question because she's been doing all the physical property work in these 3 field sites. And Jenifer, if you want to just jump in and tell them what you saw.
Yeah, so we actually haven't seen many changes in physical properties. We did infiltration in all 3 of those sites and there were some differences of the cover crop, but it wasn't anything drastic, especially at the long-term manure and grace net, we saw no differences. And this is part of the reason we are trying to move more towards active carbon is the physical properties are very time intensive. And if we're not really seeing much, we want to be able to find a metric that is more useful for farmers. But I do know that at least under the cover crop plots with manure, there is a chance that the cover crops are stealing water from the cash crop. But I feel like there's still more that kind of needs to be looked into. I definitely haven't looked at all the physical property data yet. But right now it seems like water wise, it's not really retaining much more water regardless of kind of what you're putting on it, which has been a bit unfortunate since that's been the majority of my work the past 2 years.
I think it would be valuable at some point if you could present some of those results despite the fact they're not the most exciting.
Oh, definitely. We still plan to publish papers and hopefully extension publications on this too. It's just kind of weeding through the data, and also with me starting a new position next week, things might just take a little bit longer to try to get that stuff published. So
well, and when you go out to look at those fields, if you would allow a curious soil scientist to dig a few holes in them, I'll volunteer to accompany. That would be great. I'd love to take a look at that.
You're always welcome to come out. But what's going to happen at that field site is we're going to completely invert everything. The main reason we're doing that is because after 6 years of heavy manure application, we've developed like this manure pack on the surface. And so if you take a soil core, I mean, it's, the first few inches is all manure. So we've decided to do something different and completely perform an inversion tillage event on that. So they won't look the way they are now much longer.
This is Barry. Can you hear me?
Yes, sir.
I just went for 2 days to Stuckenholz's soil test lab here in Twin, do their 2-day school on soil and fertilizer, et cetera. And those comments were made. I assume that was Mike. Mike's my neighbor. I think I'd recognize his voice, but not sure. They had the same issues where you get to the point where you get nothing but manure and you can't get seed to soil, that you get poor germination. So that's a problem that they're recognizing with all the manure applications, particularly dairy manure repeatedly. Oh, food for thought.
Interesting. We've got a lot of people on the call. I'm going to quit asking questions, and we'll deal with the awkward silence until someone speaks up. How about that?
I'm wondering with the mallow, would it work kind of like a perennial grass where if you graze it really heavy in the fall, you could cut some life out of it? I know that works with like cheatgrass, but I don't know in a biennial if that would work very well.
Yeah, good point. And surprisingly, where they shy away from it, they'll prune it during the season. After a frost, it's one of the first things they eat if you go into a stockpiled pasture. I've got sheep on this particular field now, and it literally gets grubbed in the ground, and it is just tougher. Like, it's tough. And so it's still there come springtime, along with all the little kids that have germinated in the fall, most of which you can kill with that, even the minimum till. It is the tough ones that slide around your chisel points or whatever you're doing. I just don't moldboard. I don't even own one. And I have used sweeps, but I only did it once. I did twist shovels for years and years. But this is a situation where I'm looking for a clean seed bed with a weed that is very determined to survive and wiggles around these points. And I only set the teeth on the roller harrow, maybe just a cut, so they're stiff on the ground to help bury the residue. And there's not that much left of that anyway. Now I don't have to do that much of that. But it's just a question of having a decent seed bed so that I'm not throwing my money away, and I'm running out of seasons to try stuff too. I suppose that's part of it. That goes with the deal. But once I decide which of these grasses maybe has a better fit to my property, then they'll go outside across the rest of the farm and the pivot and everything else. But that's one of the reasons why I want a good seeding, is because I'm going to test productivity and how it performs, survival and everything else. I'll have 3 different mixes. But good thought. Yeah, I've tried that. It helps, knocks it back, but those big ones, it doesn't take them. But Tyson's on this deal, and Tyson tells me he can kill it in the yard with a shovel. So why not kill it that way? It's just, how long a time does it take for all these soil food web issues to come back to where they're really going to cycle these nutrients? And that's one of the reasons why I want to do something here. It's nutrient loaded, and I want to help control that. I don't want to get into nitrate poisoning or any other issues with this feed. And so I'm trying to get a much better balance on it. Once it gets rolling, I can take it from there, but we'll just see.
So Barry, another thought for you would be, I don't know if you have any alfalfa seed producers in your area, but if one of them had an alfalfa crowner, would be a tool kind of specifically made for that job.
We were talking about that this morning with one of my neighbors, and trying to find one in the weed pile, and then set the draft on I'll run it on a 4440 and see if I can push it down in there without tearing everything apart on the tractor and the implement. But that was a discussion I had this very morning with a friend of mine. Yeah, same idea. Prune them off. That's the way you used to do alfalfa. My place, and Mike can tell you, there's places you can dig for 3 feet, and there's places you can't keep the shovel upright. So rocks are an issue. That's why I ended up planting grass. I quit farming, planted grass. So I appreciate it, guys. Those are the kind of things I'm looking for. You know, somebody's been there, done that, or has another idea we haven't talked about.
I see Taryn jump back on. Taryn, did you want to just ask that question? He was posing a question about.
I'm sorry, I couldn't find my unmute on Zoom.
Okay, all right, there you are.
No, it was interesting when you said that the manure just wasn't breaking down out there. Marlon, he wrote something there too as something that could, you know, potentially look at as to why that's not cycling through the system. And I was just wondering if there was a test done or anything on that manure, because sometimes I don't know if you mentioned it was dairy manure on some of those operations. They're heavy and keeping the cows, you know, pumped full of antibiotics for mastitis and things like that. I just was wondering if there was any possibility that there was some kind of carryover there that would keep it from being able to be broke down by the microbes.
Yeah, I mean, no, we didn't do any testing on the manure other than we do the basic chemical properties, nutrient analysis, things like that. But you know, we're not manipulating the manure after we apply it, so it's just sitting on the surface. And you know, when you're applying 50 to like 30 tons basically a year of dry manure, it adds up quite a bit, and I'm sure it's breaking down somewhere in there in that layer, but not as fast as you think it would, you know, if you don't disc it in. So it definitely builds up pretty quickly and makes germination of your crop pretty difficult.
Hey, Robert, can we follow that a little bit more? Are you talking about your sort of age stacked manure accumulating, or the compost that you've applied? Are they both accumulating?
No, this is the scrape solids from the feedlot that we apply to the cover crop project that I talked about a little bit earlier. So the cover crop project is strip till versus no till, strip till versus conventional till, manure versus no manure, and then we also have a cover crop versus no cover crop in that project.
Okay, thanks. Yeah, from our experience applying 5 or even 10 tons of compost, dairy compost annually, it's gone. We can't even find it 3 to 6 months later.
Yeah.
So, you know, age stack manure or scrape solids, it's a whole different animal, I suppose.
Yeah, it is.
On the rates that you're applying at too were really pretty extreme, weren't they?
Yeah, they are pretty extreme. It's 30 tons per acre that's dry. So, you know, you're putting on 60 tons. It seems pretty extreme, but it can be quite typical for some of the dairymen. So that's why we do it. So it's not a good idea to over apply manure. Manure is good to a point.
Hey, Robert, a question for you. Have you guys taken a PLFA test, or have you measured earthworms per cubic foot in those plots?
No, we haven't. You know, it would be interesting to do that. I always had some interest in looking at the earthworm populations. Because yeah, you can, wow, when you dig into those manured plots, it's amazing how many earthworms are in there. Yeah, it'd be worth investigating.
See, we've rolled over to 2:30. If anyone's got a burning question, they haven't blurted it out yet. I think now is your time before we wrap here.
I would like to ask Robert one more thing. So our farm here in Western Idaho, we live next to Darren. We've hauled manure out by the truckload for decades, right? And it really did a lot to bring our organic matter up from like the 1.5% up towards 2, which seemed to be kind of the range you guys were working with if I read your graph right. but then for us, it really tapered off. And I was just wondering if you had any ideas on the growth really tapered off, I should say. So I was just wondering if you had any expectations for future on these projects. If you expect that organic matter rate to keep climbing?
Actually, it looks like that. And, but eventually we kind of hit a ceiling and it levels off. So right now we're around 3%. And I think that, if we keep adding it, we've done some modeling, and the modeling would suggest that the soil organic carbon is going to keep building for the next 50 to 100 years, but I don't see that happening. We've kind of hit a plateau around 3% or so, and we didn't get much higher than that.
Anyone else? Steve, did you have a comment? Steve Schuyler?
Well, I was just gonna mention to Barry, Sean, you remember when we did the slate test out on the demo farm? One of the fields had been tilled 2 times with the horse disc. And I took a sample out of that field and then took a sample out of the field that hadn't been tilled. But the field that had been tilled, when we did the slate test, didn't break down as quickly as we thought it would. So to maybe add to Barry's many thoughts, that field was a high-speed disc, that horse, and it had been tilled twice, and it didn't appear to us like it ruined the structure of the soil. So maybe a pass, a tillage pass isn't that bad once in a while, as bad as that sounds.
That's the direction I'm leaning, Steve. But disking isn't an option. I got 3 of them. They're all broken, and I never bothered to fix them. So, but I think I'm leaning that way because I think I see the soil rebuilding on my own place, and I'm just I'm not organic, but if I can stay away from that chemical input, I think it'll be a healthier environment for my livestock.
Well, and it sounds like getting those ones that are been in there for more than a year. That's kind of the mechanical removal.
Well, Steve's retired. Yeah, Steve's retired, and I have 2 shovels, so he can come on out and we'll both sit there and chop them.
Well, now we know what you're going to do with your time, Steve.
That's right. Yep.
Thanks, man. Yeah.
I hear he's getting bored being retired, so he needs work to do.
Anytime.
Regarding the mallow, do you know if there are any biocontrols for that, like insects that you can release? That
I have not seen any indication of. And I keep scratching this thing constantly, and I've had input from a great variety of sources, brought a lot of information in, and I put it through the Soil Champion deal, and I went from never till to never herbicide. But I had 2 guys, in fact, one of them's going to speak in Burley on the 3rd, Jimmy Emons, told me that the degree of soil health that he envisions I have, I can damn near do either or, and it will not be a major upset in my soil health program over time. And I had 2 comments along those lines. Another champion out of North Dakota who was a neighbor of Gabe Brown. So I have confidence that if I do that, my concern is not chemical issues. It will recover from the trauma, and I'll be back in business, because I'm not going back to continuous tillage. I will get a seeding, and if I get a seeding, it's no-till from now on.
That's an interesting thought, though, Rob, and I'm curious if folks were, if they wanted to reach out to an entomologist or someone with more expertise along these lines of biocontrol, what might be a good venue.
I have talked to Shane New at the Soil Health Academy. And so we'll get some input on that after things thaw out and we get take chance to take samples and such.
Yeah, because I thought the University of Idaho had an entomologist or someone working on like biocontrol. I mean, I know it's actively occurring in our state, biocontrol of weeds. And maybe you might want to, or I can find the information and put you in touch with that person.
And you bet I'll talk to you, Mike, and see if we can get a hold of them and see where we're going to go. I would like to make a choice so I can plant this spring and get this established. And like I said, these are test trials to decide what I'm going to do in terms of species diversity across the entire property.
Yeah, so I guess biocontrol is not an option at this point.
If it works, I'm willing.
Yeah, I don't think you'd have the
depends on how restrictive it would be.
Yeah, I don't think you'd have the proper time frame to allow it to take place.
Okay. But it might have value down the road, Mike. I don't know. Be worth at least talking.
Yeah, it's an interesting topic, and I need to make a note on getting someone on one of these 5-for-5s that might want to talk a little bit about biocontrol. But hey, I'm looking at
Montana. Well, you need to go, but this fellow in Montana that's making 7 ton of feed through regenerative grazing with no fertilizer, he's trimmed his costs by over $125 an acre just in the nitrogen he used to apply without species diversity. It's incredible what he's doing. The legumes are almost non-existent in his fields.
That is pretty amazing.
Oh, it's amazing. He needs to get on a talk sooner or later. He's got a story to tell. He gets them on podcasts through that outlet in Montana, but
well, let's trade some
day for me.
Let's trade some emails on that, Barry, and we'll see what we can do.
Yeah, I'm more than willing. Okay. Thank you so much, guys, for your input and listening to my questions and stuff. I appreciate the information, and we'll move on with it and find out where we go from here. Thank you.
All right. Anyone else for the good of the group before we close? I see there's some chat traffic on some entomologists that are out there. Cooper's saying there's some active biocontrol stuff to check out. Southern Idaho Bug Crew might want to check out that link.
Okay.
All right. Anyone else?
Okay. Thank you much.
You bet, Barry.
Okay. Thanks, guys.
All right. Well, folks, it's 20 till, and I think we'll wrap up here. Thank you so much for coming to the Soil Health Roundtable Round 2 for this season. I'd like to put together a Round 3 before we get busy and things start growing. So I'll try to getting something out here in the next several weeks. And with that, just bid everyone adieu, and thanks again for coming today.